Question 18. Jim has identical drinking glasses, each in the shape of a right circular cylinder with internal diameter of 3 inches. Okay, so we have a cylinder, right? And the diameter is 3 inches, so the radius of that cylinder would be 1.5 inches, half of the diameter. He pours milk from a gallon jug into each glass until it's full. If the height of the milk in each glass is about 6 inches, all right, so the height is 6. What is the largest number of milk glass? Okay, so it's about volume, all right? So this is the volume of the milk in the glass. It would have the formula from, we can get this formula from the front of your section is pi r squared h for a cylinder, right? We would just need to plug in the radius, which is 1.5 squared times the height, which is 6. So if we calculate that, let's see what we get. Pi times 1.5 squared times 6. So that gives 42.4. Okay, that's how much space, how much volume is taken up by the milk in one of the glasses. Okay. What is the large number of glasses he could pour from 1 gallon of milk? Okay, so we have 1 gallon of milk, and there's 231 cubic inches in 1 gallon. This, by the way, is measured in cubic inches, since this is inches squared times inches. So we got to convert from 1 gallon into cubic inches. That would be 231. So instead of 1 gallon, we could just use 231 inches cubed. So how many of these fit into this? It's a division problem, right? So we just take our 231, we divide that by the answer, and that gives us 5.4, okay? 5.4 glasses. So how many full glasses? That would be 5 full glasses and 1 partial glass, right? Okay, 3p minus 2 greater than or equal to 1. So right away we could solve this. Add 2, we find 3p greater than or equal to 3. And then what is the least possible value of 3p plus 2? So from this point, I won't even solve for p. What I'll do is I'll add 2 to both sides. So then I'll have 3p plus 2 is greater than or equal to 5. Okay, so that means that 5 is the extreme value here, and you could be anything above that. So 5 is the smallest possible value of that. The mass of living organisms in a lake is defined to be the biomass of the lake. If the biomass doubles each year, which of the following graphs could map that out? So that's an exponential growth, which has to look like this. So if it were adding something each year, that's when we would have a linear situation. Yeah. Choice D would be it doesn't change depending on the year. And this one is just sort of wacky. Okay. 21. In a scatter plot of this data where renewable energy consumption in the year 2000 is plotted along the x-axis, renewable energy consumption in 2010 is plotted along the y-axis, for how many data points would the line be above? Would we be above the line y equals x? Okay. So if we're y and x, if our y values are the year, 2010, and our x values are 2000, we want to be above the line y equals x. So the line y equals x represents the times when these values are equal, right? When 2000 and 2010 values for energy consumption are equal. So if we're above the line, that means that the 2010 value is larger than the 2000 value. Okay, so that's what we want to find. For how many are the 2010 value larger than the 2000? So that's certainly true for wind and geothermal and biofuels. So it seems that there are 3 that for which the gray, light gray, is taller than the dark gray. So I would say answer choice C. Of the following, which best approximates the % decrease in consumption of wood power from 2000 to 2010? So let's get the numbers for that, for wood power. So we're looking at 2.25 versus 2.0. Okay, so we have 2.25 is the original, and then the final is 2.0. So to do a percent change, that's equal to change over original times 100. Okay? So the change would be the difference between them, which would be 0.25. So we have 0.25 over the original 2.25, and then times 100. And so you could use your calculator here. So we do 0.25 divided by 2.25, and then we multiply that by 100. So we get 11.1%. Okay? That's going to be the percent change, and that's choice B. The tables below give the distribution of high temperatures in degrees Fahrenheit for city A and city B over the same 21 days in March. Which of the following is true about the data shown for these 21 days? Okay. So as I'm looking at the choices, I'm seeing they're talking about standard deviation. Now, we could enter these lists into our calculator to calculate the standard deviation. But if we know enough about standard deviation, then we can get away without having to do that. So here's what we need to know. Standard deviation is a measure of how spread out your data is. Okay? So if you have a lot of data out by the edges of your data set, meaning your extreme values, low and high, if you have a lot of values out there, then it's said that your data is very spread out. On the other hand, if you don't have a lot of information out there, most of your information is focused in the middle of your data set, then you would be said to have a small standard deviation. Okay. So if you notice, in city B, right, there are 6 individuals that all have 80. And then there are 6 individual days here that have a temperature of 76. So a lot of our data is on the extremes. Okay, so for this we would say this has a high standard deviation. And for city A, right, the vast majority of our values are at 79, which is not quite an extreme. It's sort of towards the middle, right? So we would say that this has a lower standard deviation. Okay, so what we would say is that city B has the higher. The standard deviation of city B is larger. That's answer choice B. In the circle above, segment AB is a diameter. If the length of arc ADB is 8 pi, what is the length of the radius of the circle? So ADB is 8 pi, right? That would be, since this is a diameter, that would be half the distance around the circle. So the whole distance around the circle would then be 16 pi. We also call that the circumference. And we also know the circumference is 2 pi radius, so we could set the right sides equal, and then we could divide by pi. That gets rid of the pi here, and it gets rid of the pi there. Then we could divide by 2, and we get r is equal to 8. So we know the radius would have to be 8, choice C. The polynomials f and g are defined above. Which of the following polynomials is divisible by 2x plus 3? Okay, this is a tricky question. Here is a possible way to solve it. Let's see. So, okay, so it looks like this I can factor out a 2 and an x, and then I'll be left with x squared plus 3x plus 2. Aha. So notice that that matches up with g of x, right? So I could rewrite this as 2x times g of x. Right. So if I take f of x and I add that to 3g of x, then that would be f of x is also equal to 2x g of x, right? So let's rewrite that as 2x times g of x plus 3 times g of x. And then I could factor out g of x, and I would get 2x plus 3. So now I know that that expression that I started with is factorable into g of x times 2x plus 3. So this, notice, is a factor. So the answer is actually B, because this is kind of the choice that I looked at here. Very tough question there.